Now in part 2, we will solve exercises for 7.8. See here now this integral 1 to infinity 1 over x to b dx is convergent if b is greater than 1 and divergent if b is less than or equal to 1. And see a convergence theorem. Suppose that f and g are continuous functions with f of x is greater than or equal to g of x is greater than or equal to 0 for x is greater than or equal to a. If integral f of x is convergent, then for g of x it's convergent. If it's for g of x divergent, then for f of x is divergent. Okay? Now determine whether the integral is convergent or divergent. Evaluate integrals that are convergent. Okay? Here we need to solve it, okay, as the definition of improper integral. But I want to show you the use of the convergence theorem. Okay, let's start. You can use convergence theorem to show whether this one is convergent or not. Note here that 1 over x squared plus 4, okay, this is greater than or equal to 0 because we want it to be positive if I want to use convergence theorem, and less than or equal to 1 over x squared. Why is that true? When you have a fraction a over b, okay, positive fraction, so a is positive and b is positive. Okay, I will give you a numerical example, it's easier to understand it. Assume you have 8 over 1 plus 3, okay? This one here is less than 8 over 1 because here I have made the denominator less than the previous one, 1 plus 3. So in fraction, you can make the fraction bigger when you make the denominator smaller, okay? See here, we have 1 plus 3 here, we have 1 here, okay? If I have 8 over 1, and I want to find the fraction that is less than 8, make the denominator bigger. For example, put 4 here, okay, like this. Be careful, this is true here, 8 over 1 plus 3. This is true because 1 and 3 are positive. But if not, then this need not be true. See here, for example, 4 minus 2, okay? This less than 8 over 4 is not correct because minus 2 is negative, okay? Because 8 over 4 equals 2, 8 over 2 equals 4. So be careful. You can understand these ideas by these numerical examples. So we have 1 over x squared plus 4 is greater than to 0, less than or equal to 1 over x squared. Now this one is convergent. Convergent by this here, by 2. And convergence theorem, okay? So now we have proved that it is convergent. But we should solve it because evaluate integrals that are convergent, okay? So integral 1 to infinity dx over 1 plus x, x squared plus 4 dx over x squared plus 4, this equals 1 over, we should use the definition. So write limit as t approaches infinity, integral 1 to t dx over x squared plus 4. So this equals limit as t approaches infinity of, let's integrate here, we have 1 over 2 tan inverse x over 2 from 1 to t. So substitute them here, limit as t approaches infinity, 1 over 2 tan inverse t over 2 minus half tan inverse 1 over 2. Here this is constant, so we don't have a problem with that. Here this equals 1 over 2 times tan inverse of t over 2 as t approaches infinity, as t approaches infinity, it will be pi over 2. Okay? So constant minus constant is constant, so convergent. Good? Now let's solve 21. To solve this one using the definition, you should write it like this. Minus infinity to a, choose a to be 0, because we can choose whatever we want. So minus infinity to 0 cosine 2t dt plus integral 0 to infinity cosine 2t dt. For integral minus infinity to infinity to exist, this one must exist and this one must exist. If at least one of them does not exist, the original one does not exist here. Minus infinity to infinity does not exist. Let's solve integral 0 to infinity cosine 2t. So integral 0 to infinity cosine 2t dt. This equals limit as t approaches infinity, integral 0 to t cosine 2t dt. So this equals limit as t approaches infinity, 1 over 2 sine 2t from 0 to t. Let's use another variable here instead of t approaches infinity, because we have t already here. So let's use, let me delete it and write it in better way. So limit as m approaches infinity. Okay, integral 0 to m. My name is Mahmoud, so it's good to use m. Cosine 2t dt. So this equals limit as m goes to infinity, 1 over 2 sine 2t from 0 to m. And this equals limit as m approaches infinity, half sine 2m minus 0, because sine 0 is 0. Now, this limit does not exist, because I told you in part 1 that limit cosine or sine as it goes to infinity, it's not convergent. It's divergent. So doesn't converge. You can say it's divergent, okay? So this one here is divergent, because I told you if at least one of them is divergent, then this one is divergent, okay? And we will continue in part 3. Good luck, and please like and subscribe to the video.